Welcome, geometry students, to class today on this Friday the 10th. Hope you guys are doing well. Hope you're ready to go over your test today. And here we go. First of all, we will have a quiz next week, so make sure you understand that. Also, go ahead and turn in your cumulative review right now, if you would, please. I forget what page that was. I think it was page 158, but if I'm wrong, then just ignore that. It was either 158 or 168. So please go ahead and turn your homework in now at this time. Incompletes. Obviously, today's the last day of the 9 weeks. All of your incompletes are due by today. It's pretty much common sense. So, and let's see what we have here. Let's see, Alicia, you owe me page 137. Make this pretty big here. And then Alicia, page 144, and Mike, page 144. Now, there was one assignment, Mike, that I messed up on, and you had turned it in, and I apologize to you, and I made that right. But this was a different assignment, okay? I emailed your dad about this, and he responded and told me you were working on it. So I have not gotten that assignment yet, and so all of these incompletes are definitely due by today, okay? And again, excuse my voice. My voice is still a little rough, so it'll be that way for a while. So okay, there's the incompletes, guys. So go ahead and make sure you understand that they should be turned in by today. Okay, so that's that. Everyone's taking the test, so we're good there. Go ahead and get out your test. Let's talk about these for a second. Now, first of all, please understand, guys, what's going on here is kind of like this. If you've ever seen the game show on TV called Who Wants to Be a Millionaire, and on that show they have lifelines, okay? And I think their lifelines are like call a friend, or poll the audience, or eliminate 2 out of the 4 possible multiple choice answers, just stuff like that. Well, guys, you have used 2 lifelines in the first 9 weeks, okay? And there's none left. I'm just telling you, you don't get 3. And I hope that you'll believe it. If you don't believe me, that's fine. Go ahead and test me, and you'll see. You guys were told exactly what would be on a quiz earlier, about 2 weeks ago, and you guys did not do well on the quiz, so I let you retake it the next day. I never do that. And now I'm going to give you a chance to take your tests out today and work some problems on these and get back some points. Maybe quite a few points, okay? Why are you doing that, Mr. Earhart? Well, number one, there's not enough time to let you take a retake. And so I have to do something to compensate for that. Number 2, this is the first test where you had a theorem proof. And so I'm trying to give a little leniency here, but I gotta be honest with y'all. I love y'all. I'm not mad. If I was mad, I'd be yelling. Well, I can't yell, but you get the point. If I was mad, I'd be going off. I feel bad for y'all, but I'm not gonna sit here and tell you guys everything's okay when it's not okay. All right, because it's not okay. This is really. I'm gonna explain why in a second. The main reason I'm perturbed is this problem right here. Number 18. Okay, so here's what I want you to do. Here's exactly what I want you to do. If you're not interested in getting points back on your test, then sit there very, very quietly. But if you're interested in getting points back on your test, then do exactly what I say. Exactly what I say, or you will not get any points. Get out a blank sheet of paper, perfectly blank, not scrap paper, not the back of your test, not the back of a former homework assignment, a blank sheet of paper. Put your name right here, okay? Then put your social security number. Just kidding. Put your name, okay? And then every single jot and tittle that I put on this screen, I want you to put on your sheet of paper. Everything, okay? I'm going to tell you exactly what to write down. I want you to take really good notes, and I want you to earn back the points that you've lost, okay? So here we go. You ready? Get out your test, please. And if you're interested in getting points back on your test, whether you were in the 20s, which some of you were, or whether you were in the 90s, which some of you were, if you want to get some points back, then get out your tests and get out a blank sheet of paper. Let's go. Now let's talk about number 18. Everybody turn your test to number 18. This problem alone was worth 2.8 times 9, 72, 18. This problem alone was worth 25.2 points. Look at that. Number 18 was worth 25.2 points. And you might say, Mr. Earhart, wow, that's not fair. Are you kidding? Seriously? I would have loved to have had a teacher when I was in high school or college who made the question worth 25 points that, number one, he told me would be on the test, and number two, he pre-worked the problem for me. And that's what I did. I took this theorem and I proved it for you. And I told you to be on the test. All you had to do was memorize it, guys. You should be thankful that I put problems like this on your test worth 25.2 points, and which I told you would, would be on there, and I pre-worked it ahead of time. And by the way, as we work through this, you're going to see there was like 3 or 4 things you had to memorize, and that was it. And I'm going to prove that. I'm going to show that to you, okay? So on your sheet of paper, I want you to write this down. Let me pause and say that again. I gave you a problem that was worth 25 points. And it was a problem. That's like giving you a word problem and pre-working it out for you, and then making it worth 25 points, and then telling you it's going to be on your test, and then putting it on your test. Guys, I was so fair on this. So, on your sheet of paper, I want you to write this. I want you to write number 18. Go ahead and write that down. Now, I went over all this on your notes on the video. I'm going to do it again today. When you are asked to prove a theorem, the first thing you do is you draw a figure. Most of you didn't even draw a figure, guys. Look what it says. If 2 parallel lines are cut by a transversal, all you have to do is go like this. Wow, okay? Then, this is the proof part, alternate interior angles are congruent. So you knew you had to put alternate interior angles on here. So I think in your notes, I put a 2 here and a 3 here, I believe. Now, I mean, guys, you didn't have to memorize this. It says it right here. 2 parallel lines cut by a transversal. You just had to write what it said. And then it said, you're proving alternate interior angles are congruent. So you knew you had to put alternate interior angles on here. So far you've had to memorize nothing. Then, this is what you had to memorize. You had to memorize that you're putting the number 1 here. So far, let's list out what you have to memorize. You had to memorize everything I'm putting on the screen, guys. You write down, okay? Everything on this screen, you write down. So far, you've had to memorize one thing. Put angle 1, okay? Now, next, I told you to list out your given and list out your proof. Well, let's come over here. You can call these lines whatever you want to call them. So there's no memorization. You can call this A, you can call this B, you can call this C, okay? Now, what are you given? Well, I taught you guys your given is your if part. So it's right here. 2 parallel lines cut by a transversal. So your given is A is parallel to B, comma, C is a what? Transversal. I mean, it's right here, guys. If that's your given, 2 parallel lines are cut by transversal. Then is the proof part. What are you proving? Alternate interior angles are congruent. Well, what's your alternate interior angles? Angle 2 congruent to angle 3. So far you've had to memorize nothing but one thing, okay? Because all of this was written up here for you. Now, here's all that you needed to memorize right here. You needed to memorize you were dealing with vertical angles. Write that down. And you needed to memorize you were dealing with corresponding angles. That's it. Nothing else. This is all you had to do for the proof, guys. It was so easy. Put your given right here, okay? Maybe not. Okay, I give up. Put your given right here. We know that. Now to do that, we know to do that. Now here's the only two things you need to memorize. Everything else fell into place. You had to remember you had vertical angles. Okay, no problem, vertical angles. So angles 1 and 2 are what? Vertical angles. Write all this down. How do I know that? Definition of vertical angles. And then, because they're vertical, you had to state that angle 1 is congruent to angle 2. And how do we know that? Because we know that vertical angles are congruent. So all that you had to remember was vertical angles. Then next, you had to remember what? Corresponding angles. So here we go. We know that angles 1 and 3 are corresponding angles. Definition of corresponding angles. And then when two lines are parallel, and we know they're parallel because we said it right here, we know that corresponding angles are congruent. So angle 1 is congruent to angle 3. There we go. And of course, what reason do we put? Well, we put corresponding angles congruent. Now look what you have. You're done. What are you trying to prove? You're trying to prove that angle 2 is congruent to angle 3. Well, look what you have here. You have angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3. So if 2 is congruent to 1 and 1 is congruent to 3, we can definitely state that angle 2 is congruent to angle 3. Transitive. And we're done. Now guys, I'm a pretty reasonable teacher, and you might say, well, Mr. Earhart, this is dumb, this is a waste of time. Look, you're welcome to your opinion, but the whole idea of memorizing proofs is the same reason you memorize footwork in basketball. Using the left foot on the right side of the hoop for a layup, or using the right foot on the left side of the hoop for a layup, or making sure that when you transition off the volleyball net, you open to the setter, then you step, then cross, and you should be at your spot where you start your approach from. Just stuff like that. You practice that until it's repetition. Okay? And so it's the same thing here. When we're trying to memorize proofs, I'm just trying to help you learn and practice the steps, the mindset that goes into these. And guys, just so you know, before the year's over, we're going to be proving, if we have time, where Pythagorean's theorem came from, where sine and cosine came from, all kinds of stuff. And you're going to have to learn these, okay? And I'm sorry my voice is so bad, but it is what it is. So this was not unreasonable. Your teacher allowed this problem to be worth 25 points to help you. To help you. I told you it would be on there, and I gave you the whole thing worked out for you. Now, I'm not mad at you. I'm just saying, guys, I was fair. Okay? Now, let me stop and say this. I have a feeling this video is going to go the entire hour. Okay? If that happens, listen to me, guys. Listen carefully. Whenever this video is over, whenever class is over, you immediately stop. Now listen to me. You take your test papers, there's 3 pages. You turn them in, and underneath those 3 pages, you turn in all of the notebook pages that you took notes on today. And make sure your name is on those notebook pages, okay? Alright, so in case the bell rings, I've now told you what to do. When the bell rings, you turn in your 3 pages of tests, and you turn in the notes you took in class today, and I'll decide how I'm going to work on the points for your test, okay? Alright, so let's take some more notes. Now do understand, students, if you didn't miss a problem, then you really can't take notes on it, okay? But if you missed a problem, take notes on it, alright? Okay, let's continue on. Okay, let's take a look at number 19. Now, students, here's why I want to talk about number 19. Now listen, I want you to know that I'm reasonable. I made each step on this proof worth 1.5 points. Now I believe I think there was 4 or 5 steps. The most you could have missed was around 6 or 7 points. Now, let's say you missed 2 or 3 more problems on the test, and you ended up with an 88 or an 87. Well, you've got your 5 bonus points from your review sheet, so if you add those 5 points back in, then you're back up to a 92 or a 93. So guys, if you're doing the review sheets like you're supposed to, and you're doing the best you can on these problems, I make sure that these proofs here don't hurt you so badly you can't get an A, okay? I make sure of that. Now this was really a pretty simple proof, okay? Watch. You know that angles 1 and 4 are supplementary, okay? And you know that angles 1 and 3 are a what? Linear pair. I told you that when we went over the test. So you know angles 1 and 3 are also what? Supplementary. Now, think about this. Please, students, think about this. Angle 4 is supplementary to what angle? Angle 1. Angle 3 is supplementary to what angle? 1. So angles 4 and 3 are supplementary to the same angle. We have a theorem, guys. You're supposed to know these. The theorem says if 2 angles are supplementary to the same angle, then those 2 angles are congruent. So look, it's going to be really, really easy to state that 3 is congruent to 4. And guys, once I state that 3 is congruent to 4, they're what type of angles? What are 3 and 4? Are they alternate interior? No. Are they alternate exterior? No. Are they consecutive interior? No. They're corresponding angles, okay? And so, if you'll think this through, all you had to do was state that 1 and 4 are supplementary, that 1 and 3 are supplementary, then state that 3 and 4 are congruent, and then as soon as you state that 3 and 4 are congruent, you can then state that these 2 lines are parallel right here, okay? So here we go. And this was really, a lot of you, I know Blake and Michael Long, I know some of you guys did it really in a long way, which is fine, I don't care. But there was a faster way to do this, okay? Okay, number 1, you put your given. Now, if you're trying to get points back on your test, write down everything I put up here, okay? All right, here we go. Angles 1 and 4 are supplementary, and your reason would be given, okay? Number 2. Next, state that angles 1 and 3 are what? What are they? Please don't put supplementary. You first have to state that they're a linear pair. And how do I know they're a linear pair? Definition of linear pair. The definition of a linear pair is when you have a straight line and a line coming off of it like this, okay? All right, now moving on. After you've stated that 1 and 3 are a linear pair, now you can state that angles 1 and 3 are what? Supplementary. How do we know that? Well, we have a theorem or a postulate or a corollary or something, I forget, that says linear pairs are what? Supplementary. Now look what you have, guys. You have angle 4 is supplementary to 1. Angle 3 is supplementary to 1. So we can easily state that angle 3 is congruent to angle 4 because we have a theorem that says two angles supplementary to the same angle are what? Congruent. Okay? And now look, you just stated that 3 and 4 are congruent. And what are 3 and 4? They're corresponding angles. And we have a theorem that says when two lines are cut by a transversal in such a way that corresponding angles are congruent, then the two lines are parallel. So we can state that A is parallel to B. And the reason would be the corresponding angles are what? Congruent. Now again, you could have missed this whole thing. Well, actually you couldn't have, guys. Anyone can put the given. You know to do that. Okay? The most you should have missed on this was 4 steps. 1, 2, 3, 4. And each step was 1.5 points off for this part of the quiz or this part of the test here. So 6 points is the most you should have lost off this. That's very reasonable. You could still very easily get an A. Okay? Alright, let's continue on. Now, I know that I'm jumping around a lot on the test, but I want to show you things, okay? Now, please turn in your test to the first page. There seem to be a lot of issues with skew and oblique. So, how do I want you to take notes on your sheet of paper? Well, I want you to write down some stuff here, okay? Well, let's not write that down. Let me first of all show you something. A lot of you, okay, here's segment GD right here. And a lot of you said, okay, AB, that was probably, AB was the most popular wrong answer. AB is skew because it doesn't intersect BD and it doesn't lie in the same plane, which I understand that, but actually, I know this is a really tough question to ask you guys, but actually AB and GD very easily could lie in the same plane. If I took my pencil and I drew a slanted plane like that, now you can see that AB and GD are in the same plane. Well, Mr. Arrow, that's not fair because they weren't in the same plane up here. Guys, any lines that are running the same direction like these two are could be in the same plane. When I say skew, here's what I mean. And just so you know, so far there's really nothing so far for you to write down. Okay, just listen to me. Skew is this. It's like a pencil going through a sheet of paper. Let me show you. Here's GD, okay? And GD is in this plane right here. Okay? Now look at JC. JC could never lie in the same plane as GD. It's impossible. And JC will never intersect GD. So JC would be a great example of a skew line. Same with HK, guys. Look. Here's HK. Yes, HK would pass through the plane, but it doesn't lie in the plane. Okay? A skew line, two skew lines are lines that do not intersect, and they cannot possibly lie in the same plane. Now, I guess there's really nothing for you to write down right now on your piece of paper, but just keep listening, okay? Pay attention to this, guys. A lot of you miss this. Okay, oblique lines. Now listen, oblique lines have to intersect. They have to, yes, they have to. But they look, if they don't intersect, then they're either what? If they don't intersect, then they're either skew or what else? Parallel. So we know they have to intersect. If they don't, then they're one of these types of lines here. Now, the thing about oblique lines is this. They intersect, but they can't form a right angle. So, those two lines there would not be oblique because they form a right angle. However, these two lines here intersect and they're not perpendicular. So those two lines right there would be an example of oblique lines. Now, we want to name a line that is oblique to EJ. Here's EJ. Now guys, listen. If it's oblique to EJ, then it has to intersect EJ. And a lot of you are putting stuff like this. AF or AH or FH. Guys, those lines are not intersecting EJ. Now, you definitely don't want to put ED. Yes, ED intersects EJ, that's true. But they form a right angle. That's not going to work. Here's the lines that would have worked. BE. BE intersects EJ. Okay? But there's no right angle there, so they're oblique. Or you could have said BJ. Okay? Right here. Okay? Because BJ intersects EJ, and there's not a right angle there. So out of this section here, those were the two most common mistakes, okay? And then one more thing. A plane perpendicular to a line, that's not hard, guys. Look, pretend you have a wall right here in your house. Here's a wall, okay? Well, this line right here is perpendicular to this plane right here, this wall. There's a right angle right here. Also, you could even do this. You could say this line coming out here, this line here is perpendicular to the plane because there's a right angle right here. Okay? All that you have to have for a plane and a line to be perpendicular is a right angle. So, with that in mind, I want to know a plane is perpendicular to FH. Well, here's FH right here. Right here. What plane is perpendicular to FH? Well, this top plane right here would be perpendicular to it. This side plane right here would be perpendicular to it. There's two right there. Okay? Alright. Well, let's move on. I'm not going to go over all of these. Those are the three main ones that were missed. Okay? Alright, next. Now, guys, I don't care what method you use. You guys made so many little mistakes. Some of you had a negative divided by a negative is a negative. You combine like terms wrong. A lot of stuff. I'm going to quickly solve this using linear combination. So, here we go. Okay, there we go. Now, I'm going to multiply this bottom equation here by -2. By the way, if you missed this and you want points added back onto your test, then write down everything on your paper that I'm doing here. Everything. Okay? All right, here we go. The top equation stays the same. The bottom equation is -2x, -6y, -14. -2 times x, -2 times 3y, -2 times 7. Now, look what happens. These cancel. -5, -6, -11, -19, -14, -33. Now, divide both sides by -11. Here's where a lot of you put -3 for your answer. And a negative divided by a negative is a positive. So y would be 3. And then you can substitute y in for here, or here, or here, or here. I'm going to do it right here, okay? So x plus 3 times 3 equals 7. 3 times 3 is 9. Bring the 9 over, make it a -9. And x equals -2. So your answer would be -2, 3. There we go. Okay? Now, moving on. This was not that difficult. Guys, I could not believe you missed on this. I even did. Do you understand? I set up the problems on 12 and 13 on purpose so that you would have no fractions. Okay? I did that on purpose. In other words, when you flip 1/3, you get 3. I did that on purpose so that you wouldn't have any fractions. I tried to make this as easy as possible. Okay? Now, write a linear equation. You need a point, you need a slope, and you need your formula. Now, if you missed this problem or this problem, you need to write down on your notebook paper number 12, and you should have numbered this back here 11. Okay, number this 12, and then take really good notes if you missed number 12. Now, okay, we have a point. -4, 2. We have our slope. The line you're looking for is parallel to this line. And what's the slope of this line here? 2. What do we know about parallel slopes? They're congruent. They're the same. So my slope is 2. So I'm ready for my formula. Y equals mx plus b. Y would be 2. M would be 2. X would be -4. Okay? So 2 equals -8 plus b. Add 8 to both sides and you get 10 equals b. So y equals 2x plus 10. Here we go. Let's try it down here. You're asked to write a linear equation. Now, if you're asked to write a linear equation, you need a point, the slope, and this formula. Now, I gave you a point. It's right here, -4, 2. And notice the line you're looking for is perpendicular to this line. Well, what's the slope of this line right here? The slope is -1/3. So the slope of the perpendicular line would be, well, change the sign, make it positive, flip 1/3, and you get 3. So there's your slope. So you have your m, you have your x, and you have your y. So where the y is, you put 2. Where the m is, you put 3. And where the x is, you put -4. Okay? And now it's so easy from here, guys. Look. 2 equals -12 plus b. Bring the 12 over and make it a positive 12. 14 equals b. So, we know what our m is. We know what our b is. Write your linear equation. Y equals 3x plus 14. Okay, guys, really not too difficult, okay? All right, let's continue on. Now, I really Did not find these too bad. Most of you did not miss 1, 2, 3, or 4. Most of you got these right, but I'm still going to go over these quickly. I think that'll be just about it. Yeah, that's it. So here we go. Right, vector AB is an ordered pair. Okay, here we go. Remember, you take the terminal point minus the initial point. Now, guys, I can't teach that any better. But yet some of you took initial point minus terminal point. Look, I mean, you just got to memorize it. It's terminal point minus initial point. And look what I say here. A is the initial point. So if A is your initial point, then B is your terminal point. So you put 6, 3 first for your terminal point minus then your initial point, negative 1, 5. Now look how easy this is, guys. Not to kick to kick you while you're down, but look, 6 minus negative 1, 7, 3 minus 5, negative 2. That's it. There's the answer, okay? Pretty simple. You subtracted numbers. Okay, number 2, you're adding vectors. Just adding them together. Negative 1, negative 6, negative 7. 5 and negative 3 is 2. There, you add them together. Now, guys, I went over this in your notes. I said to you, when you take the dot product of vectors, you don't get out a vector. Guys, I went over that with you. When you take the dot product of vectors, you don't get out a vector. You get out a what? Remember? A number. I had so many students put a vector for their answer right here like this. I mean, guys, I can't teach it any more simple than to say to you, when you take the dot product of two vectors, you don't get out a vector. You get out a number, okay? So here's u, negative 6, negative 3, times v, and v is negative 1, 5. Now you multiply them together, then add. So negative 6 times negative 1 is positive 6. Got it? Negative 3 times positive 5 is negative 15. And then you add those two numbers together. So when you take a positive 6 and a negative 15, you get negative 9. That's it. That's all you got to do. And then lastly, down here, two vectors are perpendicular when their dot product equals 0. Okay? So you simply take the dot product of these two vectors right here, and if you get 0, they're perpendicular. If you don't, they're not. So let's see what happens. 1 times 10 is positive 10. 5 times negative 2 is negative 10. Combine those and you get 0. So your answer should have been yes, vectors are perpendicular because dot product is 0. It's that easy, guys, okay? Alright, now if you've taken really good notes on everything I've written down here, turn in your 3 pages of test, turn in all the notebook pages you just took notes on during this class period, and I will consider putting points back onto your test. But I'm not going to do this again this year, guys, okay? You've got to get serious about your test, okay? Alright, have a good day, and I will talk to you guys on Monday.